Hello everyone and welcome to this Haddad here again. We go now to lab number 11 and it's gonna be about the virtual link that I have just explained in the previous lecture. Okay, the virtual link will have two labs. This is lab 11 and then also we'll have lab number 12 and that's for the discontinuous areas. Okay, let's first see what is our lab diagram and then we go through those points to make them one by one as always. Here is our lab scenario. As you can see, it's the same as the last lecture. We have area 0 and area 1 and area 2. I have just added here the IP addresses. And our mission will be here that we have to make a virtual link in area 1 to be transit area in order to allow area 2 to be connected to the backbone area. Because at this moment, you can see there is no any connectivity or any ABR, I would say, between area 0 and area 2 to be able to be connected to each other. Okay. So this is what is the mission of the lab here, and let's go now and go through the points to see what we have to do. So here is our lab. Before I start going through the points, let me just first put the lab scenario over here. Then you can follow it on the top right of the screen. Okay, point number 1. All IP addresses are already configured as per the graph with their bridge interfaces. So what I've done also on top of this, I have just added also the bridge interfaces on each of the router. So router 1 has an IP as it's a connected network. Just to know when we share routes on OSPF that they can see the networks of router 1 or router 2 or router 3 or router 4. So as we always make it, the bridge interface of router 1 is 11.11.11.11.11. 2 is 22.22, 33, and 4, router 4 is 44. Okay, I also created this on the lab, but it's not shown here in the picture, but I think you can manage to follow it. So, point number 2, enable OSPF on all routers as per the graph and assign the proper router IDs. Let's follow it one by one, okay? I go first to router 1. And we see that router 1 has one interface, which is Ethernet 1. It's on area 0, and it has the bridge interface also, it's on Ethernet 0. We enable OSPF, I go to routing, OSPF, instances, and then here we go to the router ID. I put the router ID, and then I will enable the networks. So because router 1 has all interfaces on the backbone area, so I'll just say all on backbone area. Okay, so this is router 1 done. Router 2. We go to routing and then to OSPF. We put the router ID 2.2.2.2. And here we have router 2 has on area 0 Ethernet 1 and on area 1 Ethernet 2. And always the bridge, I will put them on area, for example, router 2, I will put it on area 1. Okay, router 3, I will put the bridge also on area 1. And router 4, I will put it on area 2. Okay, now let's create first the areas for router 2 because he's an ABR, so he has area 1 also, so it's 0.0.0.1. You can put the area ID whatever you like. I just put it 0.0.0.1. Okay, and now we have to say that the networks 192.168.12.0 for router 2/24, it is in the backbone. And then the network 192.168.23.0/24 is on area 1. And the bridge interface 22.22.22.0/24 is on area 1. Okay, now we should have a neighbor with router 1 already. Yeah, we do. Let's go to router 3 and routing OSPF. We put first the router ID because that's needed for the virtual link also. Okay, and then router 3 has also on area 1 and on area 2. So we have to create area 1 and area 2. And then the networks 192.168.23.0/24. That's going to be on area 1. I will put also the bridge interface 33.33.33.0/24. I will put it also on area 1. and then the network 192.168.34.0/24, it is on area 2. And finally, router 4, routing OSPF, we put the router ID 4.4.4.4, and then we have only area 2, so I just create a new area here, area 2, and area ID is area 2, and then we go to networks and we put everything in area 2. So router 4 has Ethernet 3, 192.168.34 network, and the bridge interface on area 2. Okay, so now router 4 has to form neighborship with router 3, that's fine. And then router 3 has to form neighborship with router 4 and router 2, that's okay. And router 2 has to form neighborship with router 1 and router 3, and then finally router 1 will form neighborship with router 2. That's fine. So we have configured properly the OSPF as required. Point number 3, check the routing table in each router. Do you see any problem? Let's see. If I go to router 1 now, and I look here inside the routes, I will see that router 1 is able to reach router 2 and router 3, but not the network of 192.168.34.0, which is on area 2, and also the bridge of router 4 as well. So if we look here in the graph, router 1 is able to see this network because it's connected to it, and then the bridge interface of router 2, and then this network, and then the bridge interface of router 3, but is not able to see this network here, and not also the bridge interface of router 4, or let's say the network here. When I say the bridge interface, I mean the network which the bridge interface is related to. Okay, so we have a problem that router 1 is not able to see anything from area 2. Okay, and the reason, because area 2 doesn't have any connection with area 0, and there is no any ABR between the two areas. Okay, if we look again now to let's see to router 4, and then also router 4, if we look here in the route, also we can see that we see the connected network to it. You will see the router 3 and the network of router 3, and then also the bridge interface of router 2. Okay, so indeed we have a problem. The problem is that router 1 over here is not able to reach anything in area 2, and also area 2 is not able to reach anything on the backbone area. Normally that's the problem because there is no ABR in between. This is okay. Checked. Fix the problem by creating the virtual link. Check the routing tables now. Is it okay? So if we go here again, I clean a little bit here. So what we need to do, we need to allow the area 2 to be connected to the backbone area. And we have said that we have to create something we call a virtual link. So the virtual link would be over here, and as I said in the explanation, that is like a tunnel whereby the traffic will be from area 0 to area 2 passing through this tunnel, and they will be like connected to each other. Okay, so because there is no ABR in between, we make the virtual link in place. Okay, so that's what we need to do now. To create the virtual link, as I said before, in this case we need to have one router, which is the ABR router, connected to the backbone, and another also router which is also connected to the transit area, and the other area from where we need to get the routing from. For example, in this case we have this one is the ABR. It is an ABR, and that's connected to the backbone area, which is very good, and he's an ABR, and also connected to the area which is the transit. But also here router 3 as well is connected to that area and to here. Then in this case we can create the virtual link on those two routers, router 2 and router 3. So let me now just explain to you how you can do that. I will go to router 2, and then we go to virtual links. Okay, and here is router 2 virtual links, and then I click plus, and here I have to put the neighbor ID. In our case the neighbor ID will be the router ID of router 3, because if we go back to this picture, we're doing the virtual link between router 2 and router 3. That means that router 3 here is the neighbor ID, and here is the router ID of router 3, which is, we know it already, it's 3.3.3.3. Okay, So that's why I told you we need to know what is the router ID when we want to configure virtual link. And then we put the transit area, in this case is area 1. Okay, that's it. So that's the part of router 2. We need to do the same on router 3. So I go to router 3 and then I go to virtual links here. It's inside the OSPF. And then I will say the neighbor ID is 2.2.2.2 and the transit area that I would like to have is area 1. Okay, based on our diagram. And here we go. Now if I go to router 1 now and we wait a little bit, directly you can see it directly showed now the network which is the bridge interface connected to it 44.44.44.0, and that's on router 4. Okay, so also you now see the 192.168.34.0. Okay, and if we go now to router 4, there we go also to routing OSPF, and then also router 4 is able to reach the networks of router 1. Point number 4 is done. So the route table is okay now. To secure the virtual link, put a password with MD5. So if we look here again, when we were doing the virtual link, it was without any password. And that's some type of security issue that we may face. That's why we can also, on MikroTik, put a password. So the neighbor router which are doing the virtual link together, they should match the same password in order to form the virtual link. Okay, to do that we have to go to router 2 again, and inside virtual link that we have created, if we double click on it, you can see here we have authentication, and you have 3 types. None, which we have it now, there is no password. Simple, you put a password but it's clear text, that means it's not encrypted, and it is better than none, but still if someone is able to capture the traffic of OSPF, he can see the password. The best to do is to put MD5, okay? So you put MD5 and you put the password, for example, 123456. Okay, that's from one side. And the second side, we have to go to router 3. But before I do that, let me show you that because we have put the password, then now directly the virtual link is down and the router 1 is not able to get any more the routes from the area 2, okay? So we have to go to router 3 and we have to do the same. We go here and we put it here MD5 and we put 123456. Okay, and okay. And then we go now to router 1. In the routing table, in a moment, we will have to see now that the networks which are in area 2 will be seen on router 1. Okay, here we go. We can see that they showed up directly. So the authentication has matched, and then the virtual link is again up, it's working, and then in this case router 1 can see the network of area 2. So to secure the virtual link, put a password with MD5. We have done that, and check if all routers are shown again. Yes, that's how you can configure virtual link on MikroTik routers. It's very easy. It's only that you need to understand the concept of virtual link, why we need it and where we have to apply it. And then the configuration is just as simple as you have seen now. Okay, so this lab number 11 is finished. Now we have to go to lab number 12. That's also about the virtual link, but for discontinuous areas. I hope that this lab has been informative for you, and I'll see you in the upcoming